was similar to the case I explained, where we use 4 Dell PowerEdge ingest servers at the edge sites. These are the garages where the vehicles would come in. As soon as the hard drives and SSDs were pulled from the car logger into the JBOD, this automated ingest workflows would launch and start capturing the insights in the data and transfer top 2 to 5% data to the regional data center, and rest of the data split between the regional data center and public cloud, depending on their data privacy and safety requirements. And this entire system was able to reduce the time it took to get to the relevant data by 90%, get the right type of data to AV and ML developers, and improve their productivity by 50%. And then overall system is in place in a way that you avoid multiple copies of data, replicas of data, avoid storing large amount of data in expensive storage tiers, and manage the entire data lifecycling through a user-defined, context-oriented controls, and get to a decent amount of storage and IT infrastructure spend. So that's how you kind of think about data being an enterprise resource, and shifting left in terms of preparing for the data and identifying relevance in data and transfer that early, as opposed to transfer everything and then make multiple copies and operate on those separately. And with the data scale that we see in the projections with all the forecasters, this is an unavoidable scenario. At some point, shifting left on data is going to be a requirement. While we look at data from an engineering point of view, the second developing thing we see is this unification and standardization effort across the infrastructure tiers, IT layers, as well as increased and continued emphasis around the security and DevOps aspects. So wanted to spend a few minutes on that area as well. So data consumers in the AI space are typically data science teams who are really looking to get curated set of data sets where they can just start using that data set to do their perception training and model development to be more productive and effective. This data is often supplied by the software engineers and data engineers who are looking to build more robust, reusable, scalable pipelines. And while all of these has to be done on top of IT managed or IT provided infrastructure capacity and processes and collaboration in place. So in order to solve for this type of a tier dependent organization structure, a framework has to be in place where you start with unifying your underneath infrastructure. On top of it, you lay out your security and DevOps processes, and then on top of put together a framework where each of the data pipeline developers can contribute their code, but leverage everybody else's code and collaborate essentially to build data pipeline. And these pipelines can be deployed on variety of heterogeneous infrastructure and at a runtime or in dynamic manner. And that overall global orchestration across infrastructure, DevSecOps processes, as well as pipeline code is the capability our DataOps platform brings to the table, and it has functionality catering to all 4 types of the users. And any solution that you would want to consider would have to feed into all these 4 organizations abstracted out for the optimum productivity to happen. With Dell, our approach has been we enable this edge to core to cloud DataOps framework platform with specific use cases around data ingest and AI/ML data pipelines. With Dell technologies, customers can kind of get smart edges, edge data centers, and core data centers, as well as gateway connectivity to all major public cloud ecosystem. And then all of the solution kind of gets deployed across the infrastructure tiers that I mentioned as well. The last part is about majority of the data that ADAS AV companies capture is either video or image based, and then there are a lot of other sensor data that are associated with camera. The second set of capabilities that we have developed is around providing the data operators as well as data scientists an ability to interactively explore large amount of video and image data and identify frames of interest to label or use it for their training and validation exercises from model development point of view. So the core problem that we saw is around this loop of data cleansing or data wrangling versus model development, where a lot of time is spent in identifying the data, and then a lot less, like a 30% time, as per Larry, the survey earlier, in the model development phase. And the current state-of-the-art solutions are around doing a lot more labeling or and spending more time and money to kind of get more data labeled and use that as a brute force approach to try and find a higher accuracy model performance. A counter or in addition to that effort, what we can bring to table is this data explorer capability. This is a interactive UI data science workbench, where essentially we take large amount of video and image data and cluster them based on the latent structure in the data, give the user an ability to search and explore this data through an interactive UI. As they find images or frames that are of interest to them, applying their human intuition, they can use social media like and dislike type of feedback to the model that we are running underneath, and a system would go and search and find similar images. Through few iterations, you can get to a much smaller subset from a fairly large amount of video data that you can then pass it to your labeling teams or use directly for training and validation. What we have seen is this reduces amount of time it takes to get to that data, as well as reduces a number of frames that you would end up labeling. Once you use this data to train your model, you can bring back the model prediction, meaning the ground truth label and the prediction score. And then we have additional capabilities, which is called analyze and compare, where we can truly look at your model performance from a data point of view and provide you metrics and interactivity around your model performance and identify places where your model is tripping in terms of performance, identify those data frames where model is poorly performing. Humans can then look at it and understand how machine sees a particular image versus human intuition, and then drive a productivity improvement through that interactive cycle. So overall, we build a data science workbench which will allow you to explore and search image and video data, identify subset for training and validation, and then bring in your model performance metrics to again look at the rest of the data set and improve that cycle rapidly. And last point is, as data evolves, as you get new data, we also provide functionality around how the new data is converging or diverging with respect to your rest of your data in the ecosystem. So this also reduces a lot of time that is spent in terms of finding the novelty in the data set or divergence in data set. So this functionality is as an addition to the DataOps platform that we have, and combination of these two features could help solve the problems that I talked about. So here's how the data gets clustered. This is a video data clustered over a case segmentation method, where each of the color changes are where scene is changing in the video. So think of a driving video where if you're making a left turn, your scenery would change compared to you keep driving on the same road. So these clusters represent change in the video. Each cluster can be browsed through these smaller thumbnail images that you see on the right, and then when you find things that you like, you can explore. So that's all I prepared for this webinar. Hopefully you got a broad overview of how you can look at shifting left on your data, how you can apply this modern data science toolkits to reduce the amount of video and image data that you have to sift through to find interesting images, and then use overall framework approach to standardize and unify your infrastructure, processes, and code while maintaining agility and innovation. With that, I'll pass it back to Amanda for Q&A, and thank you for listening.
Thank you for that, Kunal and Lawrence, for your presentations. Just a reminder to the audience, you can still submit questions for our speaker through the Ask a Question box on screen. Now we're going to take a couple of questions that have already come in. First up, does clustering help in deriving structured data from the unstructured data in image or other forms collected?
So the short answer is yes, it does, but the type of clustering really depends on underneath features vector space that you're looking at. Our approach has been to kind of build a feature vector based on the latent structure of the images, but we also work with customers on their custom featuring algorithms and onboard them into our platform, and happy to discuss that more offline on that topic.
All right, thanks, Kunal. Next up, for data ops, where does the data reside and is it encrypted?
So answer is yes, all of the data that flows to the system and at rest is encrypted. There are a variety of configuration options where customers can choose to store data at edges, local data center, and cloud, and within cloud also various different virtual private VPC tenants. So all of that is configurable in our data ops platform, and entire data set remains in customer's control. Accredata control plane does not see that data in an unencrypted form or nor have an access beyond the flow point of view.
All right, thank you, Kunal. Well, with that, we are at the end of our webinar today. I'd like to thank Kunal Vasavada and Lawrence Civilo, as well as our audience, for joining us. And thank you to everyone who submitted questions. We'll supply our speakers with any that we didn't get to today so that they can reply by email. As a reminder, you can download a PDF of today's slides under the Event Resources tab on screen. In a moment, a survey will pop up. Please tell us what you thought of our program by answering these 3 questions. This webinar will be available on demand for the next year, and an email will be sent to everyone who registered as soon as the archive is ready. Once again, thank you for watching.